So,
hello everyone, this is the first video of the pre-recorded problem sets. In this video we're going to go over two problems. We're going to go over 114 and 212. Please make sure you guys review these before you come to the recitation sections. So let's start. 114, let me get my colors right, go with this. Alright, so 114 gives you the following graph. It gives you something, an acceleration graph, so it'll give you something that looks like this. And this is at 1 second, 2, 3, and 4. And this axis is time in seconds, and this is acceleration. The y-axis is acceleration with respect to t, and this is in meters per second squared. The value, the amplitude there is 10, and from 3 seconds to 4 seconds, we have negative 10. So this is what the graph looks like. The problem asks us to find the equation of the line for the different time intervals. So for the first second, from 0 to 1, we want to find the equation of the line. From 1 to 2, or 1 to 3, I'm sorry, what's the equation of the line, and then 3 to 4. So let's start with A. A asks us to find the equation line for the time interval from 0, less than or equal, or less than t, or t is greater than 0 and t is less than 1 second. So we're just looking at this time interval right here for part A. So looking at this and knowing the equation of the line, where the equation of the line we could think of as A of t is equal to mt plus b. And we can relate this to y equals mx plus b, where y is where our y-axis is acceleration right here, and our x-axis is time in seconds. So looking at this first one, we can see that we have a slope of 0. So there's no slope here, and we then want to look at where does this cross the y-intercept, or the y-axis, and we see it crosses at 10. So we can write the equation of the first line as just A of t equals to 0t, because we don't have a slope, plus 10. So we can rewrite this as A of t equals 10. And that's the equation of the line, and our units for this are going to be meters per second squared. Now for B, we're looking at the time interval between 1 second, and 3 seconds. Now, looking at this section right here, we see that there isn't a slope, and the line, or the value of the line, is actually at 0. So if we're filling this out, this equation is going to be 0t, because there's no slope, plus our y-intercept, or where does this cross the y-axis at? It's at 0, so we have plus 0. So for this time interval, we have A of t of 0 equals 0 meters per second squared. Excuse me. Now the third one is looking at the third time interval, from 3 seconds to 4 seconds. Now, we can follow the same procedures we have for the other two problems, and we can, once again, looking at the slope of the line right here, we know that the slope of the line is 0t, and our y-intercept is at negative 10. So this is plus negative 10. So we know that the equation of the line is A of t is equal to negative 10 meters per second squared. So these are the answers to parts A, B, and C of problem 1-4. Now we're going to move on to 212. This one's a little more difficult than the previous problems, and this is for the second chapter. So 2-12. We're given the following circuit. We don't expect you guys to understand circuit analysis yet. If you're going into the electrical engineering side of things, you'll understand this later in your Circuits 1 or Circuits 2 class. But for right now, it's just important to understand the math behind this problem. So we're given the following drawing or schematic drawing, and this is L1 and L2. The L1 and L2 stand for two different inductances, and this circuit would reduce to the following. Where we can reduce this to just L. And the formula to reduce this to two inductances to one is given by the following equation. L equal to L1 times L2 over L1 plus L2. And we're given that L is equal to 80 millihenries, and L1 is equal to L2 plus 300 millihenries. All right, we'll be coming back to this slide. So we're asked to solve this problem using two different methods, the quadratic equation and completing the squares. So in order to do this, we first want to reduce the equation or simplify the equation so that we could solve this equation right here. So we do this by having L equal to L1 times L2 over L1 plus L2. Now, by plugging in our variables that we were given on the previous page, the 80 millihenries and the L1 equals L2 plus 300, we can then plug these into the equation to get the following. 80 equals L2 times L2 plus 300 over L2 plus L2 plus 300. Now, when we distribute this L2 in the numerator and we combine our like terms in the denominator, we get the following equation. We have 80 is equal to L2 squared plus 300 L2 over L2, 2L2 plus 300. Now, how can we reduce this a step further? We can multiply this denominator on this side to both sides. So we'll multiply, let me erase this. We will multiply 2 times L2 plus 300 on this side. This will cancel, and then we would multiply it on this side. 2 times L2 plus 300. And so we would rewrite this equation now as 80 times 2 L2 plus 300 is equal to L2 squared plus 300 L2. Okay, now we can reduce this a step further and have this be, we would then combine all of our like terms. So let's first distribute the 80 we'll distribute the 80 so that we have 160 L2 plus 2400 is equal to L2 squared plus 300 L2. Now we want to subtract the 160 L2 minus 160 L2, and we also want to subtract the 240, so that we now have L2 squared plus 140 L2 minus 2400. And this, we were then able to reduce this equation right here to this. And when we have it in this representation, we can now do the quadratic formula, and we also can do the completing the squares method. We first want to start with completing the squares. So let's do that. So we'll say part A, completing the squares. The square. So we have the following equation, right? We have L2 squared plus 140 L2 minus 2400. Is it 2400 or 24,000? Did I do my math wrong? 80, it's 24,000. I'm sorry. $24,000. And this equals 0. So this may be unfamiliar to everyone, but essentially what completing the square is doing is trying to get it in the form that we can get something that looks like, let's say, of the form A plus B, let's say B, okay, I'm sorry, let me redo this. We essentially want to have something that can reduce, we'll have an equation, say, ax squared plus bx plus c. And we want to get this into the form so that it's just a plus b over 2, I'm sorry, not ax plus b over 2, and this should equal 0. And then we can solve for the x term right here. Once we have it in this form, it makes it easier to reduce this. So let's just go through this problem. Let me erase all this. So when completing the square, what we want to do is move this 24,000 over to the other side. This would be plus 24,000. And then we have L2 squared plus 140L is equal to 24,000. Now what we want to do is get it so that we can get it into the form of, like we had before, where we have ax squared plus bx plus c. We want to then get this into a form that can be a quantity squared. So in order to do this, what we would need to get it in the form as ax plus b over 2. And this is going to get, this quantity is, these two quantities should be equal. Now in order to do this, we're going to have it as L2 squared plus 140 L2 plus 140 over 20, or 140 over 2, this quantity squared So essentially the key part of this is taking half of this 140, this b term. Now, if we do this, if we're adding the 140 over 2 squared to this side, we also have to do it to the other side as well. So we'll have 140 over 2 squared on this side. Now, once we have it this way, we can rewrite this part, this side of the equation, as L2 plus 140 over 2 squared. Oh, I'm sorry, not squared. Quantity squared is equal to 24,000 plus 140 over 2 squared, and this comes out to be 28,900. Now, the whole point of this is find our values of L. So we do this by taking the square root of this to reduce that side, and we'll take the square root of this. So we can rewrite this now as L2 plus 70, 140 over 2 is 70, is equal to the square root of 280 or 28,900. Now we'll subtract the 70. We'll subtract the 70 from this side. We'll subtract on both sides, so we have L2 is now equal to minus 70 plus or minus, because this is a square root, so, and because it was a square term right here, we know that L2 will contain two answers. And those two answers are going to be plus or minus the square root of this. So we're going to have minus 70 plus or minus the square root of 28,900, which is about 170. And this is our, and then we would solve for both and see which answer would make the most sense. Now, if we subtract it, we're going to have a negative inductance. And you guys will find out later down the road that you can't have a negative inductance. So the L2 must then equal minus 70 plus, plus the 170, which is going to give us 100. And this 100 is in millihenries. We know it can't be the negative because it will give us a negative inductance, and this value, just the positive value, gives us 100 millihenries. So this is our final answer for completing the squares. So let's just review this. What do we do? We brought the constant term, this 24,000, over to the other side so that we just had two terms of L. We made sure that this A term that was in front of the L2 squared was down to 1. And that was, and we know that from the original equation. So now then, once we have it in this form, L2 plus 170, or plus 140 L2 is equal to 24,000. We then do the completing the squares method. And we do that by taking this term, that term, dividing it by 2 and squaring it so that we can complete, and that's the method of completing the squares. And if we do it on this side, right here, we also have to do it, we have to add it to this side. And after that, we just use basic algebra in order to solve for L2, and we pick and choose which answer makes sense. And because we can't have a negative inductance, we pick the positive 170 to add to the negative 70 to give us 100 millihenries. That was just one method. That was completing the squares method. And you'll find out later down the road when you have to pick and choose between completing the squares and the quadratic formula. Once you get used to completing the squares, it makes things much easier. So for this one, we want to do the quadratic. I'm just going to write quad. I can't spell right now. Quad equation. Now, we're given this equation that we solved for, L2 squared plus 140 L2 minus 24,000. And if you don't know, the quadratic equation is, we can think of this as if we look at it in terms of ax squared plus bx plus c, the quadratic equation is minus b plus or minus the square root of of b squared minus 4ac over 2a. So this is our standard quadratic formula. Now if we look at our original equation, we know that a is equal to 1, b is equal to 140, and c is equal to minus 24,000. Now what we want to do is just plug these values into the quadratic formula, and that will give us our answer. So let's just plug it in. Minus 140 plus or minus the square root of 140 squared minus 4 times 1 times negative 24,000 over 2 times 1. Now this should give us minus 140, should be minus 140 plus or minus the square root of 115,600. This would then reduce to minus 140 plus or minus 340 divided by 2. And as we see, if we divide everything by 2, we have minus 70 plus or minus 170, which is the exact same thing that we got when we were completing the squares right here. Minus 70 plus or minus, right here. Minus 70 plus or minus 170. And the same reason, and this is L2 equal to this, where L2 is the variable that we're solving for. So L2, and the same process as before, we know we can't have negative inductance, so L2 has to equal minus 70 plus positive 170, which gives us 100 millihenries. So right here we demonstrated two different procedures using the quadratic equation and completing the squares. So I hope you guys found this video helpful and useful, and make sure you review it and know this inside and out.